Welcome, Sharad Institute of Technology, College of Engineering, Yendra. From the Department of Mechatronics Engineering, I am MRS RS Sazne, Assistant Professor. Welcome. We are offering Open Elective Third for the final year as Micro Electromechanical Systems. MEMS course has 6 modules. Module 1, Introduction to MEMS and Microsystems. Unit 2, Materials for MEMS and Microsystems. 3rd, Microsystems and their working principles. 4th, Microfabrication. 5th, Transducers. 6th, MEMS packaging and reliability. What is meant by MEMS, Micro Electromechanical Systems? Is a process technology used to create tiny integrated devices or systems that combine mechanical and electrical components. They are fabricated using integrated circuits, batch processing techniques, and can range in a size from few micrometers to millimeters. First chapter deals with the introduction to the MEMS and microsystems, in which history of MEMS development, scaling of micromechanical devices, intrinsic characteristics of MEMS, applications of MEMS in various industries, multidisciplinary nature of microsystem design and manufacture, microsystems and microelectronics we are going to learn. In most general form, MEMS consists of microstructures, microsensors, microactuators and microelectronics, all integrated onto the same silicon chip. Microsensors detects the changes in the system environment by measuring mechanical, thermal, magnetic, chemical or electromagnetic information. These inputs are given to the microelectronics, which processes this information and signal, and microactuators to react and create some form of changes to the environment. In a MEMS system, the devices will have the size ranging from 1 micron to 1 mm. So you can visualize from this picture that how smaller size components will be manufactured in MEMS devices. There are various application areas of MEMS. In automotive sector, in electronic sectors, medical sector, communication sector and defense sector, we are having various types of applications of MEMS. Unit 2 comprises of materials for MEMS and microsystems. As the MEMS devices are in smaller size and has to sustain the environmental changing conditions, so the material will be silicon compatible material, piezoelectric crystals, polymers, shape memory alloys, packaging materials, important material properties and physical effects. The view shows the silicon material used for the MEMS devices. Silicon compatible material system has some materials as silicon, silicon oxide and nitride, thin film metals and polymers. You can also use shape memory alloys, polymers, gallium arsenide and other group elements for the MEMS devices. There are some natural piezoelectric materials which can be used for the various applications. Unit 3 comprises of microsystems and their working principle, in which we are going to learn about the microsensors, which measures the analog world and convert it to the digital electronics. Sensors bridges the gap between the temporal effects of analog physical parameters and produce the meaningful information. In order to sense the devices, we are going to use various types of microsensors. Microactuators. Like a general actuator, a microactuator is a servo mechanism used to supply and transmit a measured amount of energy for the system or another mechanism operation is known as microactuator. These microactuators are classified into the different types based on their working principle. Unit 4, microfabrication. In order to build the MEMS devices, we are going to learn various types of techniques, in which photolithography, physical vapor deposition, chemical vapor deposition, bulk micromanufacturing, surface micromachining, Diga process can be used. Unit 5, transducers. We are going to use various types of sensors and actuators as a transducer. On the basis of their electrical signal or electronic working principle, they are classified as capacitive, electrostatic, piezoelectric, ferroelectric, electromagnetic and triboelectric transducers. Unit 6 deals with the MEMS packaging and reliability, in which key design and packaging considerations, types of packaging solutions and quality control and reliability we are going to study. As we know that MEMS devices has the smaller size, so as it is an electronic device, it will have the effect of environmental conditions like temperature, pressure and moisture. So MEMS package will support the system. It will give protection from the environment and the electrical connections to the other system components. The package should support and protect the device from the thermal and mechanical shock, vibration, high acceleration, particles and other physical damage during the storage and operation of the part, and at the same time enable interaction with the environment in order to measure or affect the desired physical and chemical parameters. This graphic shows the advanced packaging module of MEMS, in which substrate, MEMS die and encapsulation will fulfill the requirements of MEMS device. There are some application areas of MEMS in micro engines, inertial sensors, pressure sensors, optical MEMS and fluid MEMS. This glimpses shows the application of MEMS devices in the human assistant, in which hearing aid, inertial sensors, pressure sensors, mobility system devices, microfluidics for drug delivery, microsurgical tools can be used or can be made from the MEMS applications. This picture shows the automotive application of MEMS, in which various parameters related with the car system can be sensed by the sensors and will be sent to the actuator in order to have the whole control on the automotive. There are some commercial applications of MEMS. In inkjet cartridge, we are going to use MEMS devices, digital mirror device, micro mirror switch, accelerometer and pressure sensor. Thank you.